Hello students, let's start the questions. The molality of the solution they are asking you to calculate for a urea solution. So what is molality, students? Molality is equal to mass of solute that is given upon molar mass of the solute multiplied by mass of solvent multiplied by 1000. So let us substitute. Molality is equal to how much mass is given? 15.20 multiplied by 1000 upon molar mass of solute is 60 and the solvent is 150 gram. So if you solve this, you will get nearly 1.688, that is gram mole in kg inverse. So the answer here is first option. Let's see the next one. When sodium chloride is dissolved in water, the boiling point of water, elevation in boiling point is a colligative property. When you are adding NaCl to water, means you are adding a solute, and so there will be increase or elevation in the boiling point. So answer is first option. Let's see the next one. The solutions of different substances pairs they are given. They are asking you which of the following solution will be isotonic to each other. Isotonic solutions are those whose osmotic pressures they are same. How the osmotic pressures will be same? If the number of particles will be same for two solutions. So let us first calculate it. Here the concentrations which are given, they play a very important role, but as all the options they have the same concentrations, let us first calculate only the number of ions the solutions will form. Let's see the first option. Calcium nitrate will form 3 ions, that is 2 from nitrate and 1 from calcium. So for the first option, N dash for the first one will be 2 plus 1, that is 3, and here it will be 2 plus 1, that is again 3. For the second option, it will be 2 and 3. For the next option, it will be 2 and 1. This is urea, NH2CO, NH2, which is a non-electrolyte. For this, it will be 3, and this is again urea, so it will be 1. So where you have same number of particles, that is the first option. You will have 3 and 3, that is number of particles for both the solutions are same, and so they will be isotonic. So the answer is first option. The millimoles of nitrogen gas. Now here if you see some of the things which are given, let us first write down. For any aqueous solution, solubility of a gas will depend on its mole fraction. So let us write the partial pressure of nitrogen is given, that is 0.96 bar. Henry's constant is given, that is Kh, which is 76.48 kilobar. Let us convert this to bar, so that is 76480 bar. Now according to Henry's law, mole fraction of any gas, here nitrogen, is equal to the partial pressure of nitrogen upon Henry's constant. So let us substitute the values. So it will be 0.96 upon 76480. If you calculate this, this will come to 1.25 into 10 raised to minus 5. Now here the other solution, this solution is formed by bubbling nitrogen in water. So the other component is water. Students, you know that 1 liter of water has molarity equal to number of moles, that is 55.55. So how you got this, student? 18 gram of water corresponds to 1 mole. Therefore 1000 gram corresponds to 1000 divided by 18. So this will give you 55.55. So the number of moles of water here, they are 55.55. So mole fraction of nitrogen is equal to number of moles of nitrogen upon total moles, that is nitrogen moles plus moles of water, that is 55.55. In comparison to this, this is negligible, that is 1.25 into 10 raised to minus 5. So we neglect this, and therefore the 1.25 into 10 raised to minus 5 is equal to number of moles of nitrogen upon 55.55. So this will give you the number of moles of nitrogen, that is equal to 1.25 into 10 raised to minus 5 multiplied by 55.55. So this you will get it at 69.37 into 10 raised to minus 5, or 6.937 into 10 raised to minus 4 moles. But if you see the option, student, they want the answer in millimoles, and therefore let us multiply the answer by 1000. So that is in millimoles, moles in millimoles, it will be 6.937 into 10 raised to minus 4 into 10 raised to 3, that is 1000. So you will get 0.693 millimoles. So the answer here is second option. Let's see the next one. The molarity. They are asking you to calculate molarity. What is molarity, students? Molarity is equal to number of moles of the solute per volume of the solution in liter or dm cube. So let us first calculate the number of moles. Here they have given the mass as 15 gram. So number of moles is given mass of the solute upon molar mass of the solute. Given mass is 15 gram. Molar mass is 60 gram. So the number of moles will come to 0.25. So those are the moles. Now let us substitute the moles in the equation. So see that molarity is equal to number of moles, that is 0.25 upon volume of the solution, that is 0.5. So you get the answer as 0.5 mole per dm cube. So the answer here is second option. See the next one. The next question is, they want the expression for elevation of boiling point and molar mass. What is elevation in boiling point? That is delta TB is directly proportional to molality. Now what is molality, students? Molality, if I want this, I will replace this by the ebullioscopic constant, that is delta TB is equal to Kb into M. Now let us substitute, that is M2 is equal to Kb W2 upon W1 delta TB. So what you will have, M2 is equal to Kb W2 delta TB W1. So the answer here is first option. Molarity is the number of moles of the solute present per dm cube of the solution. So answer here is first option. Let's see the next one. In cold countries, ice frozen on road is melted by spraying salt like. Now here the application of lowering or depression in freezing point is used. Whenever a salt is added on ice, then the freezing point of water is lower down, and therefore the deposited ice can easily be removed because the freezing point decreases, and usually the salts that are used are NaCl and CaCl2. So here the answer is second option. Let's see the next one. Now here they are asking you to calculate the percent dissociation of the solute. Now which solute they have given is potassium ferricyanide, that is K3 FeCN6. Let us split this, student, to see the number of ions. It will give 3K plus and FeCN6 3 minus. So this will be 3 plus 1. So here N dash value is 4. Now let us write what things are given. Molality of the solution is given, that is 0.02. N dash we have calculated 4. The depression in the freezing point is given, that is minus 0.084 degrees Celsius. Pure water freezes at 0 degrees Celsius. Therefore we can calculate the depression in freezing point, that is delta TF is equal to TF minus that of this. So it will be 0 minus 0.084. So that is equal to 0.084 degree Celsius. Now the formula here, the cryoscopic constant which is given is 1.86. Formula what we will be using is delta TF is equal to I KF into molality. So this is 0.084 is equal to I multiplied by 1.86 and 0.02. If you solve this, that is I is equal to 0.084 upon 1.86 multiplied by 0.02. So this you will get as 2.258. You got the value of I. Now what is the formula for alpha, student? Alpha is equal to I minus 1 N dash minus 1. So that is 2.258 minus 1 upon 4 minus 1. So you will get 1.258 upon 3. So this you get as 0.419. Now they are asking in percent, so you have to multiply this by 100. So the answer is 41.9%, which is nearly 42%. So the answer here is first option. Let's see the next one. Here they have given a graph of vapor pressure versus the mole fraction of the second component. Now students, if you draw the graph is something like this. For an ideal gas, if I say this is A point and this is B point, then we have three type of interactions, that is the pure solvent AA interaction, then we have pure solute, that is BB interaction, and after mixing them you get AB interactions. Now if AA, that is solute solvent and solute solvent in the solution interactions, they all are same, then you get what you call it as a ideal solution, that is following Raoult's law. But here in the graph, if you see, they are showing an elevation like this, means there is an increase in the vapor pressure as compared to the ideal line. Now what this means is that the vapor pressure has increased, and when the vapor pressure of the solution will increase, student, if this AB interactions they are weaker as compared to AA or BB interactions, and therefore in the solution AB interactions they are weaker than or smaller than AA or BB interactions. So answer here is third option. Let's see the next question. The magnitude of delta TF, that is depression in freezing point, depends on. Depression in freezing point is solvent dependent, and concentration of the solution also decides the depression, and therefore the answer here is third option, that is nature of the solvent and concentration of the solution. Let's see the next one. Which of the following pairs of solutions will be isotonic? To understand the isotonic concept, we should have the same osmotic pressure for the first and the second solution. Now here, as only the concentration and the solute nature is given, so how to calculate this, student? You have to multiply the concentration by the number of particles that solute will form. So if first option, it will be 1 molar, so it will be 1 multiplied by 2 ions it will give, so this will become 2 here. Now if I take this will be 1 multiplied by, it will give 3 ions, so it will be 3. So both the N dash factors what we have calculated here, they are different. Let us see the next one. For the second option, it will be 1.5 multiplied by 2, that will give you 3, and here it will be 2.5 multiplied by, for urea N dash is 1, so this will be 2.5. So this is also not isotonic. Let's see the next one. The third option, that is 1.5 multiplied by, it will give you 4 particles. So it will be 4, you will get 6 here, and this will be 2 multiplied by, this will give you 3 factors, that is 2 from sodium and 1 from sulfate, so this will give you 6. So they both the solutions, they are isotonic to each other. Let us try D also. It will be 1 multiplied by 2, and this will be 2 multiplied by 3. So this is 2 and 3. So which is isotonic? Means it is the third option. I hope you have understood all the questions properly. So please do like my video and share it with your friends, and please subscribe to my channel to get more such videos. Thank you, students.